Hello, my name is Paul Haverfield. I work for Hewlett Packard in our Asia Pacific Storage Division, and I'm in the role of Principal Technologist. Today, I'd like to spend a few moments in taking you through a bit of a journey with virtualization and coming to some understandings around some areas of storage technology within virtualization that HP believes are critical for you to maximize your success when embarking on a virtualization journey. So first of all, the smartphone games, Angry Birds, has a lot in common with the virtual server hypervisors like Windows Hyper-V, VMware, and Citrix. Now, just for a moment, just think, what it would be like to run Angry Birds on a very old smartphone platform and what type of experience you would obtain. And, it wouldn't be very pleasant, wouldn't be much fun to try and run Angry Birds on an old smartphone with, poor display technology, very old processor technology, poor color reproduction, etc. Well, it turns out, it's a very similar experience if you try and run a modern server hypervisor such as VMware on very old storage. It ends up not being a very pleasant experience at all, and you end up having a lot of performance problems and a lot of performance bottlenecks that are very difficult to resolve and eliminate from your system. So first of all, one of the key attributes of virtualization to understand is it's quite a disruptive technology. It has a pretty big impact on organizations when you move from a fully physically provisioned or traditionally provisioned infrastructure environment into a virtual server environment. Things like administrators' roles are going to change. People are going to take on some new skills. Outside maybe the traditional server space, they're going to learn storage, maybe some networking. There's going to be some new challenges around management, particularly with abstraction of hardware in a virtual server world. A lot of issues typically experienced and that exist at the hardware layer, because the hardware layer becomes abstracted and virtualized, you need to have a good management capability within your virtual server world to be able to map end-to-end your virtual machine through the hypervisor, through the physical server, through to the storage, and then also inside the storage so as you can get an end-to-end view of the performance components that will be contributing towards any one particular guest OS performance experience. And HP, we firmly believe that storage is critical to successful virtualization. And not just any storage, very modern storage that is actually being designed for a virtual server world. So storage that has been designed for you to deploy multiple mixed workloads with a very high sharing, very high consolidation ratio. This type of storage architecture will enable you to get the most out of your virtualization project. So what we see a lot with customers is, they'll embark on a virtualization project and they'll reuse existing storage that they have. Some of this storage might be quite old. A lot of the storage architectures that are still in use today are, actually 10 to 20 years old in terms of the core architecture. And this actually means that some of these storage architectures were invented, actually before Netscape Navigator or Netscape Communicator, before the internet really became of age. So it's no surprise that when customers really try and load up more virtualized workloads onto older legacy storage technologies, that they quickly find that they have limitations in how much they can grow their hypervisor cluster. They have limitations around the workloads that you can deploy in terms of mixing transactional workloads or data warehouse workloads You might have to do a lot of micromanagement of your backups. So you really don't achieve the agility and the flexibility that you're after by virtualizing together multiple workloads into a modern hypervisor environment. So 3PAR is a storage technology which is very young. It's less than around 10 years old in terms of the original core design of 3PAR. And one of the core attributes of 3PAR is that it was actually designed to address the needs of a modern hypervisor, a modern highly virtualized workload environment. So what we typically see within 3PAR in the virtual server world is we see customers can deploy what we call a very high ratio of multi-tenancy. We can have a lot of different workloads, a lot of different applications coexisting together without them stepping on each other's toes and without them impacting on each other within any sort of negative impact of performance. So this is sort of what we like to call, very happy multi-tenancy, happy coexistence. All of the workloads, get along quite well, just like good neighbors might get along quite well in an apartment block. Now, virtualization is a technology that's definitely starting to mature. It's been around for quite a few years now, and we're now getting towards the plateau of productivity in terms of maturity of virtualization. And now, originally, storage virtualization as well as server virtualization initially is typically a financial imperative. So it's typically a financial initiative that customers will embark upon to reduce capital expenditure, reduce some operating expenditure, as well as achieving more with less overall. So it's a financial initiative. So one of the key financial metrics in terms of how customers measure their success with virtualization is what we call virtual machines per physical machine, or virtual machine density. And what we see is typically customers might start in a testing and development environment. They'll get some flexibility and agility, and they might have 2 to 4 virtual machines per physical machine. As they move up the curve and as they grow confidence and they achieve greater virtualization of production workloads, they might move up to around 5 to 10 virtual machines per physical machine. And definitely, the greater virtual machine density that you're able to achieve within your infrastructure, the greater the return on investment that you're going to achieve from your virtualization project. So one of the key attributes to virtual machine density in terms of what will impact and govern ultimate VM density is, without doubt, the storage infrastructure. So let's take a look at that now and just see how 3PAR can help maximize your VM density. So 3PAR has a few fundamental core technologies that contribute together to eliminate storage bottlenecks within a typical hypervisor mixed workload environment. These technologies are system-wide striping, the mesh active controller design, as well as the specific mixed workload optimization features that we've incorporated into the silicon chip, or the brains of a 3PAR storage controller system. So first of all, system-wide striping. So very briefly, your virtual machine data stores are automatically distributed or striped across all of the system resources within a 3PAR cluster array. So this isn't just striped across the physical disk drives themselves, but striped across all of the actual controller nodes. So this is what we call complete striping. So your VMDKs, your VM data stores, are perfectly balanced across all of the system resources within a 3PAR cluster. And the good thing is this takes place autonomically, just as a normal component of the provisioning process within 3PAR. You don't have to micromanage your workloads, you don't have to micromanage your planning, you don't have to make a lot of complex decisions up front and do a lot of planning within Excel spreadsheets to map out LUNs and work out, can application A coexist on with application B. This just all happens for you autonomically by the 3PAR array, and it's very easy and non-disruptive to optimize later on. So the Mesh Active Controller design is another feature here that helps us a lot within virtual server environments. All controllers, all server nodes within a 3PAR cluster are actively contributing performance input into all of your virtual machines. So I mentioned earlier, the data files, the VMDKs, they're not only striped across the actual physical disk spindles, but they're striped across the controllers as well. So you don't just get the capability of a single controller delivering horsepower into your virtual machine. You can get the performance capability of 8 separate controllers delivering horsepower into your virtual machine. The next one is mixed workload optimization, and I'm just going to have a look at this one in a little bit more detail. So first of all, just before I look at the mixed workload, what is it about legacy storage that is contributing towards this unpleasant experience with virtualized workloads? So legacy storage typically is a dual controller storage system, and we typically find that we have bottlenecks at 3 different places within the legacy storage array. So these are typically the back-end disk spindles as well. First of all, typically the RAID sets will be laid out quite statically on the back-end spindles. So we don't have a lot of wide striping. In fact, we don't have any real striping in terms of dynamic striping at all. It's all very statically laid out and hard-coded or hard-bound to static RAID sets on these back-end spindles. Next, the controller interconnect will typically only be a single or maybe a double controller interconnect, which doesn't have the bandwidth of a high-speed cluster interconnect. And then the controllers themselves are a bottleneck in typically with the dual controller array. Any one LUN or any one virtual volume can only be accessed through one controller at a time. This is what's called an active-passive controller architecture. So your one LUN that could have multiple VMDKs on it will only ever be able to access the capability of a single controller within this dual controller storage architecture. Whereas if we compare this to a modern virtualized storage, for example, which is 3PAR, what 3PAR has is a completely balanced active full mesh cluster design. So every node, every storage controller within the 3PAR cluster is connected to every other node by a very high speed interconnect network. This is a dedicated network connected together through a PCIe device, which is the 3PAR ASIC or the 3PAR brains. It's where we implement all of the special storage functions within 3PAR that really need to be implemented in hardware for you to obtain the best performance for your virtual server workloads. So now just looking at our mixed workloads. Now, I'm assuming everybody here listening to this, can understand this basic concept of a truck, a goods truck or freight truck, driving along a highway, single lane highway that is, and you're in a normal passenger vehicle. You come up behind the truck and you have to apply the brakes. You have to slow down. So in this analogy, this is very similar to a typical dual controller storage array in which your LUN or your volume will be operating on one controller, and you'll have a combination of small I/O requests with large I/O requests coming in through the same host ports on the single controller. And what will typically happen is that the large requests will take longer to process, and these will slow down the small requests while the large requests are processed. And this is very similar to what happens on a single lane highway where you come up behind a truck and you can't overtake the truck, so you have to slow down, and just reduce your speed to the speed of the truck. What we do in 3PAR to optimize this situation is we implement, multiple high-speed lanes within the 3PAR controller, and this is actually implemented within our ASIC processor, the brains of 3PAR, where we separate out the large workload, the large I/O requests, from the small I/O requests. So as the small requests have their own dedicated high-speed lane, and the larger requests, queue up with each other in their own lane. So this enables the higher speed, small workloads to not be impacted, to just proceed along at their own pace, at their own high-speed pace, and not get slowed down or impacted by the slower speed, large request workloads. And this situation will typically happen whenever you combine like a data reporting, data warehouse, business intelligence application, along with traditional transactional applications like Exchange or Oracle SQL Server. And this is actually, this is one of the bigger problems of legacy storage within virtual server deployments today. This issue of having mixed workloads cohabitating together within the same virtual server infrastructure. And 3PAR does this, solves this problem quite admirably, and it does this autonomically. You don't have to do anything special to your planning, to your design, or your layout to take advantage of this feature. So I like to look at this, difference between legacy storage and 3PAR modern storage, like these two trains here. So on the left-hand side, we've got a very old freight train. It has two locomotives or two controllers up the front, and behind the two controllers, it has the ability to haul, quite a large number of high-capacity freight cars. So this freight train is optimized for capacity, optimized for bulk transport. This is very similar to a dual controller legacy storage array. They're typically optimized around capacity, optimized around a single workload. They're not really designed for multi-tenancy. They're not designed for multiple workloads to coexist and operate at speed. Whereas our passenger train, our high-speed Chinese passenger train on the right here, is very, very efficient. It's designed for speed. It's designed to be predictable and on time. So all of the cars within this high-speed passenger train, they all have motors, they all have engines at each wheel. So this gives the train a scale-out architecture in which each car, which is like each node in our 3PAR cluster, each car contributes to the speed of that individual car. So this is the sort of comparison here in technology, if we just think about these two different train architectures and how that translates into storage architectures. So now I'd just like to go back to something I said earlier. Virtualization, being a financially driven initiative, quite often organizations that implement virtualization, they're looking for savings in CapEx and OpEx. So 3PAR has quite a few technologies in this area that actually further contributes towards maximizing the return on your investment on your CapEx and continuously reducing OpEx in terms of simpler management and overall lower TCO. So 3PAR, first of all, has the industry's premier thin provisioning, thin technology implementation. We're very proud of this implementation. We were the pioneers in the industry with thin technologies. We actually have a guarantee program where we can guarantee to reduce your capacity requirements by 50%. We also have a industry's premier fully autonomic optimized tiering implementation to allow you to seamlessly take advantage of solid-state flash technology, higher speed first-class disk technology, and then slower speed nearline disk technology. We combine these technologies together with our adaptive optimization solution to allow you to deploy data into the array, and the array will automatically sort out the hot data, the warm data, and the cold data, and it'll place it where it needs to be without you having to have a lot of management effort. In fact, any management effort at all. So these savings, these technologies actually contribute as well to 3PAR being very green. Because we've got this thin guarantee, we optimize the data placement on the correct media technology, we can actually reduce power and cooling costs around 50%, as well as reducing floor space requirements within your data center. Now, thin technologies in particular is something very important because most vendors these days will claim they have a thin provisioning implementation. But thin provisioning is only the beginning. Thin provisioning is just the basic capability where you can create a new volume and it can start out being thinly provisioned. But what about for all your existing volumes? What about all your existing volumes that are very old? They're legacy. They've been around for a long time. They've got a lot of white space in them. You want to thin them out. You want to remove and collapse that white space when you migrate the data into 3PAR. So this is what we call get thin or thin conversion. So this is like going on a weight loss program where you want to lose weight and you find you can lose weight, but then most importantly at the end of that weight loss you want to stay thin. You want to eliminate the capability or eliminate the possibility of that chubbiness building up again. So this is what we call thin persistence, where we provide the ability for your volumes to stay thin over time. So in a virtual server environment, this is very important because in particular, you're creating virtual machines and you're deleting virtual machines. The virtual machine churn in a virtual server environment can be very, very high in some situations. So you need the ability to reclaim that space, to get the space back, return it to the storage array, return it to your virtual servers so new VMs can be created without having to increase your storage capacity. So these core technologies of starting thin, get thin, and stay thin, I'd encourage you to talk to your vendor about how their thin technology implementation addresses these and how efficiently they integrate with the hypervisor to implement space reclamation autonomically without you having to spend any management overhead time to do it. So recently at HP we introduced some new 3PAR arrays designed at the low end and mid-range. These are the HP 3PAR StoreServe 7200 and StoreServe 7400. These are purpose-built targeted arrays at the mid-range. And the great thing about these arrays is they implement exactly the same technology, exactly the same firmware, exactly the same management software as is implemented in our very high-end Tier 1 StoreServe 10,000 platform. So you can implement virtual servers on 3PAR storage. You can choose the system that meets your needs. You can grow that system and upgrade it. And if you've got a combination of systems within your organization, they'll all have exactly the same look and feel. So the one set of management skills, the one set of learning will be able to manage your high end, your mid-range, and your low end with all the same Tier 1 data services, all the same functionality. And even more, you'll have storage federation and you'll have the ability to migrate volumes seamlessly and transparently between these 3PAR arrays without any impact on your production application. So this is what we call storage without boundaries, and it's only available from HP. So thank you very much for your time today, and I'd look forward to any follow-up conversations with you, and good luck and best wishes. Thank you very much.